Hello friends, welcome back to my classroom. In this session, let's have discussion on normal distribution. A distribution having the probability density function 1 by sigma root 2 pi e power minus x minus mu whole square divided by 2 sigma square is called as normal distribution. Here this mu represents mean, sigmas represent standard deviation, and of course this sigma square will be the variance. Suppose you integrate this function from minus infinity to plus infinity, the value is going to be 1. So this is a valid probability density function. And if we draw the graph of this function, it's going to be a bell-shaped curve symmetrical about the mean. So if mean is here, mu, the graph is going to be symmetrical about mean. And since the probability from minus infinity to plus infinity is 1, the area under this curve from minus infinity to plus infinity is going to be 1. So because of the symmetry, to the right of mu, the area is going to be area under this curve, this shaded part is going to be 0.5. Similarly, to the left of mu also, the area under this curve is going to be 0.5. And if for a normal distribution, if mu is 0 and if standard deviation is 1, then the normal distribution is called as standard normal distribution. So standard normal distribution is just a particular case of normal distribution where mean is 0 and standard deviation is 1. And when you put mean 0 and standard deviation 1, the function reduces to 1 by root 2 pi e to the power minus x square by 2. Of course, the shape of the graph remains same, only that the graph will be symmetrical about mu equal to 0. So I can consider it as your y-axis. So to the left of y-axis, the area is going to be 0.5, and to the right, it's going to be 0.5. So a total area under this curve is 1 from minus infinity to plus infinity. Now the evaluation of probabilities. Suppose under normal distribution, you need to evaluate this probability that x lies between a and b. So first thing, you need to convert this to standard normal distribution. To convert that, we make a substitution z equal to x minus mu divided by sigma in this integration. So once you make this substitution, it reduces to the standard normal distribution. So then our job reduces to find the area under the curve of standard normal distribution. So if z1 and z2 are the corresponding lower and upper limits corresponding to a and b, this probability is going to be p of z1 less than z less than z2. That's equal to area from z1 to z2. So suppose you have z1 somewhere here and z2 somewhere here. We just have to find the area, this area between z1 and z2. So how to evaluate this area? You can use tools like Excel, Python, or programming with different mean and standard deviations also available. But when you want to do it manually, you will have to use the tables available. Okay, you can download the tables from website. If you just Google for normal distribution table, tables will be available in different formats. And this table, what I have got is giving you the area from minus infinity to a particular value. Say for example, I want area from minus infinity to a. So value will be available in this table. So for example, I want the area from minus infinity to 2, let us say. So I need to see for 2. So 2 is not available. You just have to see the first column till what you want the area. Suppose you want the area till 2, you just have to look for 2 in the leftmost corner, leftmost column. So 2 is available in the second table here. Yeah, you can, I have marked it, 2 is available. Against that, the area will be found 0.97725. 0.97725 will be the area from minus infinity to 2. So similarly, if you want to find the area from minus infinity to minus 0.9, so negative values, it will be available in the first table. So minus 0.9, I can find it here, minus 0.9. So area is going to be 0.18406. Suppose you want to find the area to a point with 2 decimal points. Okay, so let me take this. I want area from minus infinity to 1.15, let us say. So 1.15. So you can find the values up to 1 decimal point. So 1.1 you can find it here. So 1.1, and you have to match with 0.05 for the second decimal point. So 1.10 is this, 1.11 is this, 1.12 is this, 1.13 is this, 1.14 is this, and 1.15 is 0.87493. So this is the area from minus infinity to 1.15. So hope you have understood how to find the areas from minus infinity to any particular point. So now let us take few more examples just for better understanding. I want the probability for the standard normal distribution. I want to evaluate these probabilities. Probability that z less than 1.2. That means my second, yeah, my normal distribution curve is like this. 1.2 is somewhere here. Z less than 1.2 means it will be left to the 1.2, the point 1.2. That means it starts from minus infinity to 1.2. So I need to find the area from minus infinity to 1.2. So it's just written as area of 1.2. Okay, every time we need not mention it as minus infinity. So we understand that it is from minus infinity. So area up to 1.2. So area up to 1.2, you can check it in the table. 1.2 is here, yeah, in the second table, 1.2, and the area is 0.88493. So this is going to be 0.88493. Just a second. So next we need to find the area. Probability of z less than 1.24. So it's going to be area from area of 1.24. Area up to 1.24. And if you check for 1.24, 1.2, the same row, but 1.20, 1, 2, 3, 4. 1.24 will be 0.89251. 89251. 0.89251. And now the next question is to find the area up to minus 2.1. So you just have to see the table to the left. 0.21 minus 2.1, you can find it in this row. It is 0.01786. 0.01786. 1786. So this is the area for up to minus 2.1. Now look at this example. We do not need the area from minus infinity. We need the area from 0.46 till 1.23. So how do you find this? Suppose you want the area from 0.46 to 1.23. It's very simple. We find the area up to 1.23 and we can subtract the area up to 0.46. Okay. So area up to 1.23. How much is the area up to 1.23 is 0.89065. 0.89065, and if you subtract for 0.46, 0.46 is 0.67724. 0.67724. So if you subtract these two, you will get 0.21341. So this will be the area between these two values, 21341. And now one more example, you can look at this probability of z greater than 3.04. So this is area after 3.04. So 3.04 will be somewhere here. So 3.04 to infinity. So how do you find this area from 3.04 onwards up to infinity? So it's very simple. We know that total area is 1, and from total area, suppose I am taking this graph for explanation. So total area is 1, and up to 3.04 if we subtract the area up to 3.04, if we subtract, we will get the remaining. So this is going to be 1 minus area up to 3.04. So which will be 1 minus 3.04. If you see 3.0 is this row, 1, 2, 3, 4. 0.99882. So 0.99882, if you subtract, it's going to be 0.00119. So you can very easily calculate the probabilities less than some value, between some values, and greater than any value. Okay, so it's very simple, and this table can be used for standard normal distributions. So not for other distributions where mean is not 0 and standard deviation is not 1. You cannot use this table directly. You have to convert any other normal distribution to standard normal distribution, and then you can make use of this table. So I'll take these examples. What is given here? For the normal distribution with mean 2 and standard deviation 4, we need to evaluate these three probabilities. So I have taken three examples just for understanding, and later on you can take more examples and you can calculate the probabilities yourself. So already I have told you that to convert any normal distribution to standard, our substitution is x minus mu divided by sigma. So here mean is 2, so mu will be 2, and standard deviation sigma will be 4. So our conversion substitution will be x minus 2 divided by 4. So my first probability, required probability, is minus 6 less than x less than 3. So now in this substitution, I am going to substitute my lower limit and upper limit, and I will find the corresponding z values for the standard normal distribution. So what will happen if I put minus 6 in this? So it will be minus 6 minus 2 divided by 4. So this is minus 8 divided by 4, which is minus 2. So this will be equivalent to area from minus 2 to upper limit is 3. So 3 when I put here, it will be 3 minus 2 divided by 4, which is 1 by 4, 0.25. So minus 2 to 0.25. So now I can use the table and find the area up to 0.25 minus area up to minus 2. So if you subtract these two values, you will get the required probability. So what is area up to 0.25? That you can check very easily. Area up to 0.25, 1, 2, 3, 4, 5, 0.59871. 0.59871. 59871 59871 minus area up to -2. Okay, up to -2 is -2 is 0.2275. 0.2275, and if you subtract, you will get 0.5759. Okay, so similarly you can find the other probabilities. So I'll just quickly calculate them. So if you have understood, you can just forward this part. So z minus 2 divided by 4. Second one is probability of 1 less than x less than 5. So when you put 1 here, it will be 1 minus 2 divided by 4. So minus 1 by 4, it's going to be minus 1 by 4 is minus 0.25, and upper limit is 5. So 5, when you put 5 minus 2 is 3. 3 divided by 4 is 0.75. So this is area of 0.75 minus area of minus 0.25. So area of 0.75 is going to be you can check the table, 0.75 and minus 0.25. 0.75 is 0.7 is here, 7 5 0.77737, and negative 0.25 is negative 0.25 is 0.25 is 0.40129, and when you substitute those two values and calculate 0.77737 minus 0.40129, you will get 0.372 approximately. Okay, and the last one is finding the probability of x greater than or equal to 5. So the probability, when you convert it using this, you will get probability that z greater than or equal to 0.75. So this is area after 0.75. So it's 1 minus area of 0.75, which is 1 minus 0.40129. So when you subtract this, you are going to get 0.2266. Okay, so hope you have understood how to find the probabilities with the help of the table. So now you can solve any problem if you know the mean and standard deviation. So let me take this example. The life of a certain type of electric lamp is normally distributed with mean of 2040 and standard deviation of 60 hours. And there is a consignment of 2000 lamps. Find how many would be expected to burn for more than 2150 hours, less than 1950 hours, and between 1920 and 2160 hours. So here what is x? X is life of lamp. This is normally distributed. So what is x? The random variable x is life of lamp, and on an average the mean, it's given, mean is given as 2040, and standard deviation is also given as 60. So to convert the normal distribution to standard normal distribution, we use this substitution, x minus mean 2040 divided by 60. Okay, so what will happen now is, first we need to find the corresponding z value for x equal to 2150. So when you put x equal to 2150, z will be 2150 minus 2040 divided by 60. So if you calculate this, it's going to be approximately 1.83. So the first probability is more than 2150. So our Z should be more than 1.83. So Z more than 1.83 means area from 1.83 onwards, 1.83 to infinity. So already we have discussed, whenever you want more than some value, you just have to subtract that area from 1. So 1 minus area of 1.83 is approximately 0.96638. You can check it in the table, 0.96638, and when you subtract this, you will be getting 0.033625. Okay, so this is the probability that the life of lamp is going to be more than 2150 hours. Now the question is, after finding the probability, we need to calculate out of 2000 lamps, how many of them will be of this quality, which will burn for more than 2150. So it's very simple. Whatever probability is there, 0.033625, I just need to multiply by 2000, because 2000 lamps, out of 2000 lamps we need to calculate. So this will give you approximately 67 lamps. So 67 lamps are going to burn for more than 2150 hours. Okay. So then similarly you can calculate the number of lamps that will burn for less than 1950 hours. So method is same. You just have to change this value 2150. Instead of that, we are talking about 1950. So once you calculate this by putting 1950, you will be getting approximately minus 1.5 here. So our it is less than, so area starts from minus infinity, so minus infinity up to minus 1.5. So because my less than minus 1.5 means it will be to the left, so minus infinity to minus 1.5. More than means it will be to the right. So area up to minus 1.5, and if you check it in the table, it's going to be 0.6681, 0.06681. Let me cross check quickly. 1.5 minus 1.5 is 0.06681. That's correct. Okay, so 0.06681, and we are multiplying this with 2000 lamps, and approximately you will be having 134 lamps of this kind. Okay, so now the last question is between 1920 and 2160. So 1920 to 2160. So when you make this conversion, so when you put x is equal to 1950, you will be getting approximately, sorry, I need to take 1920. So when you put 1920, you will be getting the value of z as minus 2. And when you put x is equal to the upper one 2160, you will be getting z value as 2. So between them, so probability between 1950 and 1920 and 2160 will be equal to area from minus 2 to plus 2. So this is area of 2 minus area of negative 2. So area of 2 will be 0.97725 minus area of minus 2 will be 0.02275. So when you subtract them, you will have 0.9545. So 0.9545, you just have to multiply with 2000 lamps, and you will be getting approximately 1909 lamps that burn between 1920 to 2160 hours. Okay, so similarly, uh, I'll leave this problem just for your practice. So 1000 workers are there, that's okay. So Z is going to be X minus mean is 700 here. So X is what is X? X is the, let me read the question. The weekly wages of 1000 workers in a company are normally distributed. So X is going to be weekly wage. Okay, so weekly wage, and its mean is going to be 700 rupees, and standard deviation will be 50. So your our Z is going to be X minus mu divided by sigma. So, and remaining things between 650 and 750. So you will put 650 and calculate Z1, 750 and calculate Z2, and in between area you can calculate and multiply it by 1000 workers, which will give you 683. And similarly you can go for more than 750. So when you put 750 here, 750 minus 50, approximately, I mean, you will get Z equal to 1. So area from 1 to infinity. So that is area 1 minus area of 1. And calculate the probability, multiply by 1000, you will get 159. So hope you have understood how to solve the problems on normal distribution. And in the next class, we'll start joint probability distribution. Okay, thank you.